Hey, good afternoon. So the title of my talk is about robots and how they'll become the best testers that you've ever built. So firstly, hi. I'm probably the person that's in between you and getting more coffee or even possibly more pizza. So hopefully this talk will be kind of quick and a little bit pain-free. And maybe after, if anything I've said is of interest, feel free to grab me and we can have a chat about mobile some more. So this is my ugly mug. So firstly, hello. I'm Alan. I'm from Dublin in Ireland. And I work at Zendesk as the architect for mobile. And it's a true passion of mine to write excellent code that delivers superior user experience while maintaining a high quality bar. And with that in mind, I care deeply about automation and its role in being able to achieve that. So delivering what I want to be able to do is, in shorter loops, be able to deliver higher value to our customers with greater efficiency and with little or no toil to our engineers. And so hopefully you're here because you're either interested in mobile development or you care about test automation. But test automation isn't without its challenges. The quote's from me. Mobile test automation is relatively immature space, and the landscape is constantly evolving. Almost every release of Apple or Android or iOS or Android from Apple or Google, there's tooling changes that change the landscape. On Android, the ecosystem has evolved, where we started with just UI Automator. And then open source tools like RoboElectric came along in a quest for faster feedback loop on tests. And then we got Espresso. And Espresso was that quest for a more reliable test. And on iOS, the core APIs that are available to engineers fundamentally haven't changed. You have XEUI test and XE test. But a considerable level of effort by Apple has been put into making it a bit more scalable and a bit more robust. Here's a common myth that I encounter on a regular basis, which is that mobile test automation is hard. Reality is that as people who write code on a daily basis, maintenance can be hard when faced with lots of technical debt. Sure, it's difficult, but it's incumbent on us to improve the code that we write, and that should start with our tests. Maintaining tests is expensive. A lot of people argue that we can hire two manual testers in a cheap part of the world, and that outweighs any effort that we put into our tests. And I fundamentally disagree with that. I believe that the engineer who builds that feature should also write the unit tests, the integration tests, the end-to-end tests. It's on us as engineers to deliver a complete end-to-end solution. Automation delivers low value. Well, if you're an indie developer, if you write code yourself, sure, automation is probably, and you're building a small app, automation is probably a little bit overkill. But for a company like Zendesk, where we have a complex test matrix of language support, of plan types, of feature switches that our customers can choose, those permutations and combinations are far outstrip any amount of human effort that we could possibly hire. And so when we think about that test matrix, I often compare it to this giant ball of yarn. Everything is mixed up, it's muddled, it's confusing. When we onboard a new engineer in Zendesk and try to explain to them all the different things that can go on, legacy plans, things like that, a few minds explode. And naturally, that complexity within the business can seep into your tests. And so often people have this mental model when they think about tests. The other thing that keeps changing is the landscape. Here are all the devices that are currently supported on iOS 13. The ecosystem keeps changing, and the reality is that we can elect to test on a subsection of these devices, but the reality is that each one of those devices has a nuance or a user experience that really should be tested. Back originally, iPhone 1, we had a fixed size in terms of dimensions. We knew how big the screen was. And that was true for quite a while. And then with the iPhone 8 and iPhone 10, things really got interesting. The home button disappeared. We had this area underneath the activity indicator, what to do with that. And so the reality is that manual testing just isn't good enough anymore. So what makes a good UI test? These aren't anyone's rules. These are the things that I care most deeply about. I believe that tests should be easy to read. And what I mean by that is it should be possible from reading the test to reason about what it is that's being tested. They should be easy to write. Writing tests should be fast. And for corners of our code base, it should be easy for us to backfill missing tests when they occur. And it should be extensible. The reality is that if we can't extend our tests to meet new business needs, then what's the point? We're just wasting our time. And as I mentioned before, the ecosystem isn't as robust or solid as we might like. So we need to be able to debug issues when they occur. So in preparation for this test, I went looking for, out in the open source community, for a demo application that I could use to showcase test automation. And I stumbled across this app by Ryan Nystrom, who currently works in GitHub, but most people might know him for his open source app, GitHawk, or IG List Kit. It's a simple weather application. It has a bunch of screens. You can see a list of cities. You can click on a city. You can see the weather for today, for the hour, and for the rest of the week. And there's some search functionality to add a new city. And one of the challenges, it's probably a lesson of adopting Swift, is that this code base was originally written in Swift 3, and when you open it in the latest Xcode, errors be everywhere. So I needed to migrate it to Swift 5. So let's try and write a simple test for this application. We're going to select a location, Dublin, my hometown. We're going to verify that some of the information that's displayed on the screen. So first thing we do is we're given some base requirements. We have an application, and we know we have a city, Dublin. We query the collection view. So this sample app is based off IG List Kit, which is essentially an abstraction on top of UI collection views. So in this case, we look for an element called city, and then we click on it. We then are displayed with the weather details, and then we expand the arrow. And then we make some assertions. Now, admittedly, there's only one assertion here that checks that from the expanded section that there's a field-like section. We could be more exhaustive, but for the goal of being presentable code, I decided you get the idea. Another test that we might write is we swipe on a location, delete that location, and verify it's gone. So, I came to Sofia on Monday, so maybe I'm no longer interested in the weather in Dublin. So we'll delete the weather in Dublin, and I can forget about the wind and rain in Dublin. So let's have a look at what that looks like. So again, we have a set of initial states. So we have the city, Dublin, and we have our application. We have a whole heap of code here that mimics essentially the natural behavior of a human exploring swipe actions on an item. They swipe left and then they swipe right. That presents a delete option, and they tap on it. And then here is our simple assertion that verifies that the user is that row, that Dublin entry, is no longer present. But like I said, I got off the plane on Monday, arrived in Sofia, and wanted to keep an eye on the weather. So we're going to select the add location option. We're going to search for Sofia, and we're going to confirm that it displays on the list. So again, some basic givens. It's pretty straightforward at this point. We make tap the add button. Once the next screen is presented, we search for Sofia. We tap on the search result, and we return to the list screen. And here's the verification that verifies that the list has been presented. So, demo gods are never kind to me, so I've elected to use screen recording because it just simply never works for me, and I didn't fancy chancing my arm. So here we go. We'll run our tests. I probably should have sped them up, but didn't want to hide the fact that these are real working tests. So here, we've deleted Dublin. Success. We type in our Sofia, Bulgaria. We type it. We see it appears at the bottom of the list. And here's Dublin. We expand the list. We verify that feels like is there. Huzzah, our test passed. But what we've realized by looking at all those tests is that this is essentially what we've built, right? We have some tests that interact with a view. That in this case, I'm talking about a presenter, but let's not, I don't want to make any assumptions about people's architecture. This could be Viper. This in this case is MVP. In any case, the idea is the tests exercise a view, that view exercises a presenter, and that presenter exercises some fakes. And in this case, we're using OHTTP stubs to mock out those API calls. And to me, this feels a little bit like this, right? My spidey senses are tingling. We begin to see that our code is rapidly descending into that ball of yarn we saw before. Thinking about what I said before, the test should be easy to read. I don't know about you, but I found those tests hard to read, hard to write, and you can imagine if you wanted to insert a screen into that flow, it'd be really hard to maintain. So in my opinion, the code we just wrote met none of those goals. Everybody loves a great quote, and this quote is from a gentleman named Dennis Ritchie, who was the creator of the C programming language. I'll read it out just for posterity. With proper design, the features come cheaply. So I think this best describes the motivation when we think about patterns and how we apply them to tests. If we adopt the right pattern, we can avoid that ball of yarn that haunts me at night. We can lean on traditional software engineering theory to help us, to keep us running away, keep us on the straight and narrow, to stop us running away with ourselves, and we can learn from the power of others. So, faced with those realities, I guess here are some of the options that we could employ. We could bury our head in the sand and just keep writing those linear, brittle tests. But as we saw, or as I hope was clear by that example, those tests won't scale. And with no pattern, we simply won't succeed. BDD. So I took this screenshot this morning in my hotel room from the Calabash website. And so Calabash being an example of a popular BDD platform, framework, I just found it kind of interesting that the site is now dead. And I'm not saying that BDD is a terrible thing. It comes with great promise, right? It hits that first tick box, which is, I want tests that are easy to read. The problem in my experience is that it doesn't tick any of the other boxes. It generally is harder to maintain and harder to debug. You have that layer of abstraction and translation from that prose text of the test into the actual actions. And it makes changes super hard. And then we have page objects. In my mind, page objects is a pattern that's been adopted from the past, from Selenium WebDriver automation in the early days, and doesn't really meet the ideas that we care about today. So, we do have a solution, and that solution is robots. When I think about robots, though, I think about something like this, right? It's some machine bouncing around, exercising screens, recording the output. Unfortunately, there's a problem with one of my slides, but we'll persevere on. What I prefer to think about is think of your robot more as in a car assembly line, whereby each robot on that assembly line has maybe one or two tasks that it cares about, but actually fundamentally it doesn't do much more than that. The car then moves on to the next stage and another set of robots performs another action. So when we're writing our robots, think of it like that. We want to encapsulate a small subset of behavior. It could be a single screen or a subsection of a screen that is potentially complicated to test. So I'm going to skip past the slide that didn't render correctly. And you didn't see that. And the robot pattern builds on a well-known design pattern. These four gentlemen are known as the Gang of Four. Eric Gamma is probably the most well-known. In any case, they presented a pattern called the builder pattern. It's a creational pattern, and it's part of this book here. I have a copy. It sits on my bookshelf at home, and really it gathers dust for the most part, but it's a great reference when you need to go back and thinking about refactoring. If you don't have a copy, I very, very much recommend you get a copy. But at the core of it, the builder pattern is a pattern that allows you to do object construction in a step-by-step approach. And the bit that's most important in all of that is these words, step-by-step, right? So what we're going to do now is actually go and build that robot. So thinking back to the demo that I showed you of or the screenshots that I showed you, the app, we want to build a list robot. And that list robot will encapsulate the behavior of interacting with the list in our app. So this is just some boilerplate, but essentially we have a private computed variable of the application instance. And here we've created a select location action. For people who aren't necessarily familiar with Swift, that like pointed arrow to weather details robot is essentially the expression of our return. So what we're saying here is that when I select a location, I expect to go to another screen. We take that piece of code that was in our old linear app, we cut and paste that in here, we use a variable to express the city, and then we create an instance of the weather details robot. Here's the next function that we want to add to our robot, and we want to be able to search for cities, right? So what we're doing here is we're doing that same functions, but this function expresses selecting search. It returns the search robot instance. So when I tap on that add button, I'll create an instance of the search robot. And this type of small function extraction, when you think about your refactoring, is something Martin Fowler, I'm sure, will be very proud of. Lastly, we added a delete location method. So here is the discardable result. You're probably wondering, for people who may be not familiar with Swift, some of the ways in which you invoke this will cause the compiler to give out a warning saying, hey, you're invoking a method, but the return is not used. In a pure application, you might be worried about the return, but because of the way we're structuring our tests, sometimes it's okay to discard the result. So in this case, we're telling the compiler, I'm okay with the return being ignored. So here's our delete location. It's very similar code that you would have seen earlier. We take that collection view, we swipe, we press delete, and what's kind of not highlighted there is we return an instance of ourselves. So as you saw on the recording of the automation, when you delete an item, you don't leave the screen. So in this case, we stay on the screen that we want to be on. So let's go back to our tests. So here are our tests. So I'm going to go back through each of the 3 tests that we wrote before that were really verbose, and you'll kind of see how the pattern applies very neatly. So in this case, we start off with some initial state. So in this case, I've created a list robot and a details verifier robot. Use your judgment when you want to create, how granular you want to create your robots. In my experience of code that we've written, robots tend to get bloated and turn into God classes when you mix the behavior of navigation and interaction with verification. So by that, even for this simple example, I kind of selected to create the 2 objects. So then what we do is we invoke that list robot and we say, hey, list robot, select Dublin. And then you'll notice we automatically, because select location returns an instance of the weather details robot, we can chain calls together. So we can use that builder pattern to call steps across multiple objects. So here we're saying select the location and then expand the weather details. And then I take the verify details robot and I get it to verify that the weather details has in fact been expanded. So I think you get the idea. This is a whole lot neater than the approach previously. It ticks the box of easy to read. I think it ticks the box of easy to write. And adding new behaviors to existing screens will be a whole lot easier now. So the delete and verify, you kind of get the idea, right? We list what the one thing that I would call out is that we've encapsulated delete location rather than saying swipe left or swipe right. In your tests, you don't actually care about that, right? The test was select or swipe on a city. All I want to do is delete a city. I don't actually care how that's actually implemented. So Should our UX change, all we have to do is change the robot in the back end, in that previous layer of abstraction, right? We don't have to go change all our tests to update their behavior and to capture a new user experience. We just go, okay, I'll update my robot, but my tests stay the same. And then similarly, we invoke a robot to verify that Dublin has in fact gone. Yeah, so that's that. And then the same example, let's search for Bulgaria and let's delete it, or add it. So here is, it might seem kind of trivial, but I wanted to show that the code that I wrote did actually work. So it's the exact same tests. They're a lot leaner. They're easy to read. They're easy to write. And they do the exact same thing. They test the behavior of our application. Awesome, our test passed. So conceptually what we've seen now is that we've injected another entity in between our tests, the robots. And these robots interact with those views. And so I think you can conceptually think of every view that you could have a robot. And this then leaves us to write more and more tests without necessarily having to change a huge chunk of our architecture. One of the things that's super interesting was Swift 5. As a person who's been through, I guess, 3 major releases of Swift now in our code base, this one brought a huge bunch of challenges, but some benefits as well. So let's apply some of Swift 5 language features and see where we get to in our tests. So one of the items that was introduced in Swift 5 was this idea of property wrappers. And the reason why Delegates is still there and crossed out is if you Google it, property Delegates was the original proposal that was submitted to Apple for review. It offers the ability to extend the behavior of properties. Conceptually, it's very similar to Java annotations, but they're very solely focused on properties of objects or structs. They don't have the flexibility that are available in Java. So one of the things that I created was a construction wrapper. So here we have, the first step is to use this annotation @property wrapper. All property wrappers then are structs, and in this case, I say that we can take any object that is of type XCUI application, and essentially all we're doing is we're calling the default constructor on it. But the consequence of that is all those computed properties that we had previously. What you may not be aware of with computer properties is that every time you do .application in those tests, it will produce a new instance of that object. Moreover, what we're able to do now is just say @construction wrapper, create an instance of this object, and then when the parent object is constructed, it'll go and do the necessary work for us. Another great feature of Swift 5 is trailing closures. What's interesting here is the evolution is this idea of creating a trailing closure inside an init. So what I've done is I've created an init that takes a closure that passes an instance of itself and doesn't return anything. So this is what it looks like when you actually go to execute your test. So to me, it reads better. And this is from real experience of in Zendesk, we have a hierarchy that's pretty complicated. And as a result, using the previous approach of chaining API calls, often when you get an assertion failure or just a bug, it was often very hard to figure out where in the code the problem was, because when you just do dot and a method call and keep doing that a bunch of times, all you'll get is one red line that says, there's been an error in this like call stack, and it's not very useful. Whereas actually what we're saying here is that here are a bunch of operations that are exercised on the list robot, and then if I move on to another list, I can encapsulate those inside the closure. I think it's a little neater. So hopefully, through all of this, we're all on the same page. We've created a set of tests that are easier to read, easier to write, should be easy to extend, and are very easy to debug. We've leveraged new features from Swift 5 to reduce boilerplate and make our tests more expressive. But I wanted to talk to you also a little bit about some of the experiences I've had working at Zendesk. So one of the products we sell is a thing called Support. And with it, we ship an iOS app. It was originally an iOS app, universal app, but now with the advent of iPadOS, I felt it important to call it out. It's predominantly written in Swift. We do still have some Objective-C. Instead of using vanilla XC UI tests, we actually use Earl Grey 2. And Earl Grey 2 is an open source project from Google. It's very much inspired by Espresso. It does the exact same behaviors. It watches animation threads, it watches network calls, and gives you, or they claim, it gives the interactions it makes at the UI layer are more in line with what a user actually does, as opposed to what XCUI test does. All our mocking is provided through OHTTP stubs. That's a mouthful. And OHTTP stubs, we've created an internal framework around it that allows us to express and replace mocks at runtime during each of the tests. And one of the other things we do is we run all our UI tests on every pull request. So for every engineer who wants to merge something to master, all our tests are run on every pull request. And thinking about that simple app that we've gone through with the weather, I tried to capture some. Don't worry about it, it's intentionally meant to be small, but this is some, but not all, of the different screens that are available in our application. To be honest, I got tired of taking screenshots, but there's a whole heap of combinations and different screen property types that our application offers. We also offer different feature toggles, so a customer can switch on and off features and add different functionalities. We also support about 24 languages, and so the reality is to do localization testing, functional testing, integration tests, end-to-end tests. The reality is that doing that by hand just really doesn't work for us. The other good thing is that our Android team use Kotlin to write their tests. And so here's an example of a Kotlin test that follows the robot pattern. And hopefully you can see from these tests that it's very similar to what we wrote in iOS. One of my big hopes, and one of the things that I'm keeping an eye on, is Kotlin multi-platform, and understanding the role that it can play in terms of how much of this code we can write once in one single language and have it expressed in both. And it's something that I'm super excited about. All the code is open source. It's here on my GitHub, CodeMonster 2019. The original simple weather app, if you want to take a look at it, is available there. And another talk that is very important to me is there called Testing Robots. It's by a gentleman named Jake Wharton, who's very famous in the Android community. And yeah, so at this point, I'd like to say thank you. If anyone has any questions, I'm sure I can answer.